So in chapter 2, continuing on with what we've been doing, we're going to talk about limits. So to start with, what is a limit? So when we say the limit of the function, we're saying as x approaches some value, what happens to the y values? So the question that we're asking here is, what happens to the y values as x approaches some x value? That's the question of limits. It's saying, what's happening to my function values as x approaches something? So for example, let's look at the graph of f of x equals 2x. So I'm looking at the graph of f of x equals 2x, and I have that graphed here. So this is my graph of f of x equals 2x. And then let's say I'm looking for x values going towards 5. So here's x equals 5, and look at my graph corresponding to that. So here's the point corresponding to x equals 5. What's happening to my y values as x is getting closer to 5? Well, let's see. If I start a little bit to the right of 5, here's my curve. Now watch, I'm getting my cursor closer and closer to x equals 5. What are my y values doing? So look over here at your y values. As I get closer and closer to 5, my y values are going towards 10. Now let's go to the left. As my x values approach 5 and I travel along this curve, what are my y values doing? Going towards 10. So we would say the limit as x approaches 5 of the function 2x is equal to 10. Now formally speaking, how do you actually write this? And what is the formal definition? So let's start with the formal definition. The limit of f of x, so we're talking about the limit of a function, as x approaches c is equal to L. What does that actually mean? So this is true if the absolute value, so I'll write that here, absolute value of x minus L becomes arbitrarily small when x is any number sufficiently close, but not necessarily equal to, c. So this is your formal definition. We say that the limit of f of x approaches c is equal to L. So to say that statement, it means the absolute value of f of x and L becomes arbitrarily small when x is any number sufficiently close, but not necessarily equal to c. So I know that's very technical. Go back to our graph. What this is saying is that to talk about the limit as x approaches 5, I mean to say that's equal to 10 means if I get closer and closer to x equals 5, the distance from this point, the y value there, to 10 is smaller and smaller. That's all it's saying. So it's saying as I get closer to 5, the distance to 10 in terms of y values is also getting smaller. So all that technical is to say that. Now there is special notation that we're going to use. So the notation here, the notation is actually very important. The notation that we use is called the limit. So the limit, and then in the subscript we say x going to some number. So we say the limit as x approaches c. Let's make that a little bit bigger so you can hopefully see it. So the limit as x approaches c, then in parentheses is your function. So here's my f of x, and you say that's equal to L. So that's the notation that we're going to use. So this is really important to understand this notation. It's saying the limit as x approaches c in the subscript, that's always where the x approaches c goes, of your function is equal to L. So in our example, what did we had? We had that the limit as x approached 5, so the limit as x approached 5 of my function 2x was equal to 10. So that's how we would have written it. We would have said that the limit as I approached 5 of my function 2x was equal to 10. So let's go back to my graph. So here was my function 2x. As x approaches 5, the y values go to 10. Let's do one more example. So this is the graph of x minus 2 squared plus 1. So let's do some more examples here. Let's ask the question, what's the limit as x approaches, how about 2 of the function x minus 2 squared plus 1. So what is that equal to? So I've already graphed this for you, so x minus 2 plus 1, here's the graph of that. As I approach 2, let's see what happens. Well, from the right, so start over here, what are my y values doing? So here's my current y value. As I approach 2, so this cursor is getting closer to 2, my y values are doing what? They're decreasing to 1. What about from this side? So if I start here, here's about where my y values are. As I get closer and closer, what are my y values doing? Going to 1. So we would say the limit of that function as x approaches 2 was equal to 1. How about as x approaches 1? So go to this function here. Here's the point corresponding to 1. As I go from the right, so I'm starting over here, what are my y values doing? So as I get closer and closer to 1, they're increasing to 2. What about over here? As I get closer and closer to 1, they decrease to 2. So we say the limit as x approaches 1 of this function is 2. So let's write that. So we would say that the limit as x approaches 1 of my function, we'll just call it f of x, was equal to 2. So that's the notation for limits, and that's how you do them. You look at the graph and you say what's happening to my y values as my x values are approaching something.